Imagine hitting play on your favorite show, only for Netflix to suddenly go dark. Your movie night? Gone. Your data? Potentially lost. It's a shocking thought because we take for granted that services like Netflix are always on, right? What we need to understand is that behind every smooth streaming session, every successful online purchase, there's a constant battle against failure. If you don't grasp this core concept, your own applications will eventually crash, users will vanish, and you won't even know why your system just disappeared. But here's the kicker: software does fail. Servers go offline. Networks stutter. Even the biggest tech giants face hardware glitches every single day. So, how do they create systems that seem to defy gravity, staying online and protecting your precious data no matter what? The secret lies in a fundamental principle of modern software engineering: database replication. It's how we ensure that your data is not just safe, but always accessible. Let's break down this crucial technology. Think about your most important documents. Would you ever keep just one copy, stored in one place? Of course not. You'd back them up, maybe put a copy in the cloud, another on a hard drive. We do this because we know a single point of failure is a recipe for disaster. The same goes for the data that powers our applications. When we build a system with only one database server, we're essentially putting all our eggs in one basket. If that single server goes down, everything stops. That's where replication steps in. It's the process of creating and maintaining multiple identical copies of your database, typically on different servers. These copies are called replicas or secondaries, while the original is often called the primary or master. When data changes on the primary, those changes are quickly copied to all the replicas. This means if one server fails, another one can immediately take its place, keeping your application running smoothly. It's like having multiple backup drivers ready to take the wheel the instant the main driver gets tired. See the pattern here? We're building resilience, not just speed. Now, not all replication is created equal. There are a couple of main strategies, and each has its pros and cons. Let's look at the two big ones: synchronous and asynchronous replication. Imagine you're at a restaurant taking an order. With synchronous replication, the waiter, your primary database, won't tell the chef, your application, that the order is taken until every other chef in the kitchen, your replicas, has also written it down. It's slow, but absolutely guarantees everyone has the exact same order. On the other hand, asynchronous replication is like the waiter yelling the order to the kitchen, then immediately moving on to the next customer. The other chefs will eventually write it down, but the main chef doesn't wait for their confirmation. This is much faster for taking orders, but there's a tiny window where one chef might have an order that another hasn't received yet. So, you get blazing speed, but with a very small risk of losing a single order if the main chef suddenly collapses before the others catch up. Which method sounds like a better fit for Netflix, where millions are streaming constantly? Most replicated database systems use what we call a primary-secondary architecture. Sometimes it's called master-slave, but primary-secondary is more inclusive. In this setup, one database server is designated as the primary. This primary node is the only one that can accept changes like writing new user data, updating a movie's watched status, or processing a payment. All other servers are secondaries. They receive a constant stream of updates from the primary, ensuring their data stays consistent. Think of it like a lead conductor, the primary, and an orchestra, the secondaries. Only the conductor dictates the tempo and dynamics. The musicians follow along, playing in sync. If the conductor suddenly can't continue, an assistant conductor, a secondary, is immediately ready to step in and take over. This design ensures that all changes are funneled through one source, avoiding conflicts and keeping your data organized. Now, you might be thinking, what if the primary goes down? Isn't that still a single point of failure? And you'd be right to ask. This leads us to the genius part: automatic failover. The real magic that keeps apps like Netflix online, even when a server fails, is automatic failover. This isn't just about having backup copies, it's about intelligent systems that automatically detect a problem with the primary server and promote one of the secondaries to become the new primary, all without human intervention. It's like having a team of dedicated pit crew members constantly monitoring a race car. The instant they detect a critical engine problem, a standby car seamlessly takes its place on the track, almost before anyone in the audience notices. This process is incredibly fast, often completing in mere seconds or minutes. It minimizes downtime and prevents data loss. Remember what we said about that frustrating moment when an app goes dark? Automatic failover directly addresses that, making those outages incredibly rare. It's why critical systems today can achieve 4 nines or even 5 nines of availability, 99.99% uptime. This means less than 5 minutes of downtime per year. The ability to recover quickly and autonomously is what makes database replication truly robust and keeps our digital lives running smoothly. Let's imagine a world without replication for a moment. What would actually happen? Take an online store, for instance. If its single database server fails due to a hardware issue or a power outage, the entire website goes offline. Customers can't browse products, can't make purchases. New orders are lost. Existing order statuses disappear. The impact isn't just theoretical, it's immediate and catastrophic. Your customers lose trust, potentially abandoning your service forever. The financial cost of downtime for even a small business can be thousands of dollars per hour, and for large enterprises, it can be millions. Beyond money, there's the damage to reputation, the scramble to recover lost data, and the sheer frustration of being unable to serve your users. Ever had that happen when you were trying to pay a bill online? This is the consequence of not having a robust replication strategy in place. It's not just about tech, it's about business continuity and user experience. So, how do the big players like Netflix put this all together? They don't just use one replicated database, they use many, often spread across different data centers or even different continents. This multi-region replication means that even if an entire geographical region goes offline, say, due to a natural disaster, your show keeps streaming because another replica in a different region can pick up the slack. It's like having your document copies not just in different rooms, but in different cities. Beyond simple failover, replication also lets companies scale their read performance. Since secondaries can also serve read requests, Netflix can distribute millions of users querying movie titles across multiple servers, preventing any single server from becoming overwhelmed. This strategy is critical for handling massive user bases and ensuring low latency, no matter where you are in the world. This is not just a safety net, it's a performance booster. We've covered a lot today, from why single servers are risky to how replication, in its synchronous and asynchronous forms, provides safety and speed. We saw how the primary-secondary model organizes data flow and how automatic failover acts as an unseen guardian, ensuring your applications remain online even when individual components stumble. The key takeaway is simple: for your data to be truly safe and accessible, it needs to exist in multiple places, managed by systems that can react to failure faster than any human ever could. This understanding is crucial for anyone building or managing modern software. You now know the core secret behind why your favorite apps rarely go down. If you enjoyed diving into the resilience of databases, you'll definitely want to check out our next episode. We'll explore, but what happens when you have so much data that even a replicated database isn't enough? It's a whole new challenge, and we'll reveal the revolutionary solutions. Don't miss it!